Hello everybody! So I told you I'd make a video to do a few examples of solving equations with variables on both sides since we didn't have time in class. So I'm just going to go through a few problems here. You can follow along in your student journal. I'm on page 15. So let's look at number 6. On number 6, we are dealing with a problem that has variables on both sides, but as I have mentioned before, you want to make sure that you simplify each side. Now on the left-hand side, I can see that I do not have any distributing, but I do have like terms that I can combine. Like terms are terms that have the same variable, same exponent. When you combine like terms, combine your coefficients, and keep the variable the same. Bring down your equal sign. The other side, there are no parentheses for distributing, and there are no like terms to combine. Just going to copy that down. From here, I'm going to move my terms with variables on one side and terms with just numbers, which we call constants, to the other side. So I'm going to move my variables by adding 8x to both sides. You can do this part in your head, like I've mentioned before. That will cancel out the negative 8x on the right-hand side. To move my constants, I'm going to move my constants to the right by subtracting 8 on both sides. I like to do this in one step. You can take it one step at a time by moving your variable terms first and then moving your constants in the second step. It will cancel this out to 0. So when I go ahead to simplify here, I get 4x. 16 minus 8 is going to give me 8. I'm going to divide both sides by 4. Again, this division can definitely be done in your head. And I'm going to get x equals 2. So this one definitely has a solution. If you would like to try one on your own before you see me go through the steps on another example, please go ahead and try number 10. You can pause the video to try it on your own before I go through the steps. This would be a good time to hit pause. In doing this problem, I'm going to go ahead and I'm going to first simplify both sides. I can see that I have parentheses, which probably means I'm going to have to distribute. On the left-hand side, I'm going to distribute negative 8 to every term inside the quantity right after it. In doing so, I get 3x minus 16x minus 24. Please pay close attention to your signs. Bring down the equal sign. Now the left-hand side has more simplifying to do, but I'll do that in the next step. I don't want to do too much at once because then I can start to mess up and make mistakes where that could have been avoided by taking our time. On the right-hand side, I'm going to distribute the negative 6, giving me negative 12x minus 30. The right-hand side is completely simplified, but on the left-hand side, I have like terms to combine, which gives me negative 13x minus 24 equals, and I'm just going to re-copy this down, making sure I copy it down correctly. Then I'm going to go ahead and start moving terms from one side to the other, and I'm going to move my x's to the left, and I'm going to move my constants to the right. It doesn't matter which side you move variable terms to. I just commonly use the left-hand side out of habit. So I'm going to go ahead and I'm going to add 12x to both sides. I'm going to do it in my head this time. By adding 12x to both sides, I get a negative 1x. Remember, negative 1x can also be written as negative x. By then moving the constants to the right-hand side, the reason I want my constants to go to the right is because I put my variable terms on the left. Moving my constant terms to the right-hand side, I'm going to add 24 on both sides. if you can't do that addition in your head, you can do a little bit of work off to the side in the margin, just like that. And you'll see that you get -6. Now, I do not want the answer to -1x. I want the answer to x. So if you are left with a -1x or it's written like -x, you are not done with the problem. You need to do some division. So I'm going to divide both sides by -1, and I get x equals +6. A negative divided by a negative is always a positive value. Let's go to exercises 11 through 14. This is on page 16 of your student journal. Sorry for not mentioning that before. All right, so what we're going to do is we're going to look at number 11. Looking at number 11, you first want to distribute 24s plus, if you can't do that, 6 times 12 in your head, go off to the side and do a little bit of side work there. That's going to equal 24s. And again, 14 times 8. I'm going to take a little time to do that off to the side. I get -112. Now I'm going to start moving my variables from one side to the other. So I'm going to move my 24s to the other side by subtracting it. When I subtract 24s on both sides, like so, this is going to cancel out to 0, and this is also going to cancel out to 0, leaving me with 72 equals -112. Notice that all of my variables have canceled out. And as we learned, I'm going to zoom back up here to page 14 where we wrote down notes. If the variables cancel out and you get a false statement, the answer to your equation is no solution. So in this problem here on page 16, number 11, my variables cancel out. I get something that is not equal, so the answer is no solution. And that's what you would circle or box as your final answer. Last problem, number 12. I have some, the left-hand side looks great, so I'm just going to recopy it. On the right-hand side, I have some distributing to do. You don't need to draw those arrows when you're distributing. It's just a reminder for some people that is helpful. And I get something like this. Now, I can already see that I have what we call an identity. An identity means that you have something, anything, equal to itself. Okay? And I can see here that I have 16f plus 24 equal to the exact same thing. Okay? And if I were to start solving this, like if I subtracted 16f here and then I subtracted 16f here, notice what would happen. These would cancel out to 0, and I would be left with 24 equals 24. Another identity. Okay? So one way to tell that you have what we call infinitely many solutions is that the variables cancel out and you get a true statement. Another way to identify that you're going to have infinitely many solutions is by seeing that even before the variables cancel out, I have an identity, meaning it is exactly the same. Nothing is different, exactly the same on one side versus the other side. So there are two ways to determine if you have an answer of infinite solutions. You can also say infinitely many solutions, but that's a little bit more to write. One way is to cancel your variables and get a true statement. Another way is to have an identity. So I'm going to go back up to my notes on page 14, where we have already written down variables cancel out, get a true statement, you get infinite solutions. The other way that you get infinite solutions is if you have an identity. Okay? So you have what is called an identity, and that's here and over there. And an identity is when you have something equal to something else where they are exactly the same on both sides. So identity meaning that it's exactly the same on both sides of the equal sign. Okay, so there's, it just depends on where you want to stop with the problem. So I hope that these last few examples have helped you to finish up your homework tonight, and good luck with your practice.